Hello and welcome to our CZ4153 Blockchain Technology Development Project presentation. I'm Devyansh and I'm joined by my friends Viren and Yiheng, and we would like to present to you our decentralized exchange project. So what is a decentralized exchange? You might have already heard of centralized exchanges such as Coinbase or Crypto.com, where you can trade cryptocurrencies. These websites manage transactions and wallets centrally, meaning that the user has to trust these companies with sensitive data such as their keys. Decentralized exchanges allow you greater control over your keys, allowing you to store them in your own digital wallet such as MetaMask, instead of in the servers of some company over which you have no control.
This is the architecture of our decentralized exchange. Our client-side application is written in React.js. MetaMask digital wallet is used to communicate with the Ganache blockchain. So this blockchain will contain two groups of smart contracts. The first group contains the smart contracts ETHSwap, TokenSwap, and TokenSwap Inverse. So ETHSwap is used to buy and sell token A and token B using Ethereum. TokenSwap is used to swap token A and token B with token A. TokenSwap Inverse is used to do the same function as TokenSwap but with the inverse rate. So this first group of smart contracts will communicate with the token A and token B smart contracts for the functions transfers and approve. Now we'll go on to the features of our smart contracts. So for the first smart contract will be ETHSwap. So ETHSwap allows users to buy token A or token B using Ethereum. So users can send Ethereum to smart contract and get token A in return. So the rate is fixed at 1 Ethereum to 1000 A tokens. And it's also fixed at 1 Ethereum to 1000 B tokens. So users can also sell 1000 B tokens and get 1 Ethereum back in return.
The check button allows us to check if the rate of A divided by B or B divided by A is an integer. For example, I would like to swap 1 A token for 1 B token, the rate is 1 and therefore a swap is available. However, if I were to like to swap 3 A tokens for 2 B tokens, the rate is not an integer, therefore you will not be able to swap.
Now I'll go through the second smart contract, which is TokenSwap. So what TokenSwap allows is it allows users to swap in their B or A tokens for A or B tokens, vice versa. So in this case, we'll take a look at a small swapping process. So for Alice, she will start off with a balance of 1000 A tokens, and she will submit an order to sell 5 of her A tokens to get and receive 1 B token. So this is submitted to the limit order book in TokenSwap. And Bob, on the other hand, will have a balance of 1000 B tokens, and he will sell 1 B token for 5 A tokens. So this will be submitted to the limit order book as well. So in the end, Bob, which has sold his 5 B tokens, will have his B balance reduced by 5, and he'll receive 1 A token in return. Whereas for Alice, since she submitted an order and sold 1 A token, she'll receive 5 B tokens from Bob. For TokenSwap smart contract, we will only support limit orders. A buy limit order will only be executed at the limit price or at a lower price. So let's look at an example. So Alice decides to sell 10 of her A tokens to get 2 B tokens. Whereas for Bob, he wants to sell 2 B tokens to get 8 AA tokens. So Bob will receive 10 A tokens instead of 8 A tokens because this is at a better rate for him. Whereas for Alice, she will just receive the 2 B tokens that she initially wanted. So the limit order is only applicable to the person who submits the order at the end. Another limit order case is this. So Alice will sell 4 of her A tokens for 1 B token, and Alice will sell another 6 tokens for 1 B token. On the other hand, Bob will sell 1 of his B tokens for 5 A tokens. So the imbalance will be that Bob will receive 6 A tokens instead of 5 A tokens, as that's a better rate for him. Alice, on the other hand, will receive that 1 B token. So this is Alice. She has a initial A balance of 1000 tokens. So she will submit 2 orders. She would like to sell 4 of her A tokens for 1 B token. So the balance will minus 4. And now the balance will be minus 6. So now let's switch off to Bob. So Bob on the other hand has a balance of 1000 B tokens. He will now submit a sell order for 1 B to receive 5 A tokens. So this order will be filled instead. And Bob will receive 6 A tokens and minus 1 B token. Whereas for Alice, she'll receive the 1 B token, but one of her orders will still be inside the system. So our token swap also supports partial orders. So for example, when Alice sells 10 of her A tokens for 5 B tokens, and Bob sells one of his B tokens for 2 A tokens, only 10% of Alice's order will be filled. So in the order book, there will still be a remaining order of selling 8 A tokens for 4 B tokens. 100% of Bob's order will be filled. So the final balance for Alice and Bob will be that Alice will still have a minus 10 A tokens, so she'll be left with 990, and he will receive the 1 B token from Bob. Bob's balance on the other hand will be that he will get his 2 A tokens, and he will minus 1 B token, resulting in a balance of 999 B tokens. For the partial order, so Alice will have a balance of 1000 A tokens. She will first submit an order of selling 10 A tokens for 5 B tokens. So this went through, so she loses 10 A tokens, and there will be an order in the order book here. So now let's move on to Bob. Bob on the other hand has 1000 B tokens, and he will be selling one of it to receive 2 A tokens. So for this order, Bob's order should be fully filled. As you can see, Bob will receive his 2 A tokens and will be deducted 1 B token. And Alice will still be missing 10 A tokens from the first order that she submitted, but she will receive 1 B token instead. And there will be a swap for 4 B tokens remaining in the token book, in the order book. So now let's move on to Bob again, so that we can clear the remaining orders in the order book. So now, Bob will sell 4 of his B tokens for 8 of the A tokens. So this should be 2 plus 8, and we'll get 10 A tokens. So there will be no more orders left in the order book. Alice will receive the 5 B tokens that she wanted, and the order book has no more orders left inside. An additional feature that we've included is to display the orders made by the person. So every time an order is placed, it will be shown here at the bottom of the panel here. Another feature that we've included is also to delete the orders from the order book. So for example, this user has placed multiple orders here. Once he clicks cancel order, all of these orders that are not filled in the order book will be terminated, and the tokens will be returned back to the user.
I'll now move on to explain the codes and how the decentralized exchange is being built. The codes are all in one project called the Blockchain DEX. The code structure can be seen from the picture on the slide. The migration folder contains the files needed to deploy the Solidity codes onto the blockchain. The component folder contains the front-end React codes. The contract folder contains all the Solidity codes, while the test folder contains the test cases for the decentralized exchange. I'll now move on to further explain the Solidity codes found in the contract folder. The token A Solidity codes contains the implementation of an ERC20 tokens and its functionality. Transfer and transfer from function allows transferring of tokens to and from the contract address, while approve functions is used to approve the user to spend the tokens. Similar to token A, token B Solidity also implements the ERC20 token format and contains all the required functionality for the decentralized exchange to work. The if swap contract implements the buying and selling of A and B tokens using Ethereum. The token swap contract implements the main functionality of the decentralized exchange. It allows the swapping of tokens between A and B. It also tracks the orders and matches them according to the best rate available. Partial order is also being implemented. The next slide will explain the main function A to B with more details. The seller book contains the orders for users that want to swap B token for A token. The buy order book on the other hand contains the users that want to swap A token for B token. Function A to B allows the user to swap their A token to B token with their desired or better rates. When function A to B is called, the function will first check if there are any orders in the sell order book that has the same or better rates than what the user has chosen. If there is, the rate will be chosen and the tokens will be swapped at the desired rate. The function also implements the partial order by checking the amount of tokens available for swapping. If the user creates an order that requires more tokens than what is available, the order will be partially filled and the remaining tokens will be returned into the order book. If there are no orders in the sell order book, the orders will be returned directly into the buy order book. Function B to A is being implemented with the same logic, just that the function implements a swap of B token for A token instead. To ensure that there will not be any floating point numbers when calculating the rates, since Solidity do not provide the usage of floating points, token swap inverse is implemented to solve the issue. The implementation of token swap inverse is the same as token swap, just that the rate is opposite of token swap to ensure only rates that are of integer types are being produced. The test folder contains the test cases for the decentralized exchange. Miscellaneous test.js will test the Solidity functions that are not in the main flow of sequence. Orderbook test.js, on the other hand, will test out the logic in the Solidity codes. Some tests include buying A and B tokens with Ethereum, selling A and B tokens for Ethereum, swapping A and B tokens, swapping A and B tokens with limit orders, and swapping A and B tokens with partial fulfillment. With that, we have come to the end of the presentation. Thank you.
Hello and welcome to our CZ4153 Blockchain Technology Development Project presentation. I am Divyansh and I'm joined by my friends Viren and Yiheng, and we would like to present to you our decentralized exchange project. So what is a decentralized exchange? You might have already heard of centralized exchanges such as Coinbase or Crypto.com, where you can trade cryptocurrencies. These websites manage transactions and wallets centrally, meaning that the user has to trust these companies with sensitive data such as their keys. Decentralized exchanges allow you greater control over your keys, allowing you to store them in your own digital wallet, such as MetaMask, instead of in the servers of some company over which you have no control. Our project is one such decentralized exchange. It allows you to issue buy and sell orders for tokens. It also supports partial fulfillment of orders as well as cancellation.